talking about, right?
Mm-hmm.
Okay. Basically these. Sorry.
Hi, I'm Maddie Sofia. I'm an assistant producer at NPR with Joe's Big Idea. And I'm here at the Smithsonian with Dr. Brianna Pobner. Brianna, where are we at? Tell us what we're doing.
We are in the lab and collections of the Human Origins Program at the National Museum of Natural History.
And what is it that you do for a living?
I'm a paleoanthropologist, and so I study basically people in the deep past. I'm interested in their lifestyles and how they lived, and particularly what they ate.
Yeah, and today we're going to be talking about the origins of the paleo diet, or what people during the paleo time period actually ate.
That's right.
So what do we got here?
So here we have we have replicas of fossils from Kenya. These are our ancestors that probably first started eating a significant amount of meat. So this is a skull of a species called Homo erectus that was around about 1.8 million years ago. So for the first several million years of human evolutionary history, we were omnivores. Our ancestors were omnivores. And all of a sudden, people started eating meat from large animals, and that just hugely changed a lot of our behavior and even a lot of our skeletal biology. So brains started getting bigger, actually teeth started getting smaller because people were making tools and they were processing food outside of their mouths before they put it in their mouths.
So why did our brains start to get bigger after we started eating meat?
Well, there's an idea that since meat is is a resource that has a lot of calories kind of densely packed into a small packet, our brain is a really energetically expensive organ. It's about 2% of our body weight and takes up 20% of our energy. So where are we going to get all those calories from? You can eat a whole lot of plants, but you can eat a lot less meat. And so there is a hypothesis that eating meat basically released a constraint on the evolution of a really big brain. We have enormous brains compared to other primates and other animals.
Okay, awesome, cool. So how do we tell from these fossils that we were meat eaters?
So we can tell, we can look at the shapes of teeth, we can look at kind of general body size and shape, but actually a better way to tell if early humans were meat eaters is by looking at the tools that they made and also looking at animal fossils found in the same sites where these early humans were found to see if they were eating those animals.
Awesome. All right, you want to check out some of those?
Let's do that.
All right, cool. All right, cool.
So welcome to the office of Dr. Rick Potts, who is the leader of the Human Origins Program, the director of the Human Origins Program here. And I have laid out just a few of the tools that we have in our collection at the Smithsonian. And you're basically looking at about 2.5 million years of stone tool technology. So stone tools started out relatively simple. We know that people were making stone tools, basically knocking rocks against other rocks to get sharp flakes, kind of these sharp knives. We know that people were doing that as early as 3.3 million years ago.
Wow.
And there was a site in Kenya that was discovered relatively recently that dates stone tool making back that old. But the earliest stone toolkit was really simple. It was a round hammerstone. Mm-hmm. It was a core, which is the rock that the hammerstone was used to knock off. It's kind of the main part that these flakes were made of. But it's really the flakes that were the tools.
Okay.
And so they're sharp stone knives. And once you get a sharp stone knife, there's a whole new world of resources opened up to you.
Cool. What do we got here?
This is the oldest man-made object in the Smithsonian's collections.
What?
And this is a stone tool from a Smithsonian research site called Kangera in western Kenya. It's about 2 million years old. And the interesting thing about this site is that it's the first time that we see early humans going back to the same place over and over again to make tools and butcher animals. So it's a big shift in kind of the way that our social interaction happened around this, around meat eating and tool making.
A very important question. May I touch that?
You can definitely touch it, as long as you hold it over the cloth, because there's a nice cushion underneath here.
So like my ancestors were tooling around with this bad boy, huh?
They were tooling around with those tools.
What do I do with this?
So this was actually probably a core. And so it was like one of these where a hammerstone would have knocked off these sharp flakes. And you can really tell based on the patterns of scars on these tools or on these cores that they were used to make tools.
Wow.
And that's one big clue that this is a tool and not just kind of a rock that came out of a riverbed.
Okay, gotcha. And so these tools are related to our eating of meat then,
That's
right?
correct. And so really as soon as we see the earliest tool making, we also see the earliest meat eating. So at least 2.6 million years ago, there are fossils of animals that people butchered. So we know what those flakes were used for. They were used for butchering animals. This is a real fossil from a Smithsonian research site called Oldowan, and there are definitely marks on here made by stone knives. And so for me, in my research, this is a smoking gun. It tells me that an early human butchered this animal, in this case, a little less than 1 million years ago.
Wow.
And so I can look at a whole variety of these kinds of fossils and say, well, what kinds of animals were people eating? And what kinds of parts of those animals were they eating? Were they getting the juicy parts? Were they getting the scrappy parts? But it's really once you get a whole collection of these fossils that you can start to make those inferences. And for me, honestly, every time I pick up a fossil, particularly when I've excavated it kind of fresh out of the ground, I'm the first person touching that fossil that an ancestor of mine ate 1 million years ago, 1.5 million years ago.
Very cool.
It's fantastic. Awesome.
That is so cool. So do these tell us also about what kind of plants we were eating? I mean, were we using...
They do. And actually, we often, on the edges of tools, will find residues of plants. So sometimes, particularly, they're little microscopic starch grains that just are around in soil after plants die and these starch grains get preserved, but sometimes we can actually find them right concentrated on the edges of tools. And that gives us a sense that these tools might have been used for scraping sticks or sharpening sticks, or maybe they were used for actually digging plants out of the ground. Mm-hmm. So they can tell us about eating plants in the past.
Very cool, very cool. So these are starting to look a lot more like, tools that I would imagine
exactly.
that we would use.
They're
right?
a lot easier to recognize. And so these tools, which are teardrop shaped tools, they're part of a stone tool industry called the Acheulean. Okay. So the earliest industry is called the Oldowan. That lasted for about 1 million years. Then you get the Acheulean, which lasted for about that long, even a bit longer. What these probably were, these are actually a really efficient way of using rock to make a lot of those flakes. This one right here was a gift to the Smithsonian in 1879. It's actually one of the earliest gifts ever made to the Smithsonian for our collections. And it's from a site called Saint Acheulean in France. And that is the site after which this stone tool technology is named the Acheulean.
Wow, very cool.
And these types of tools are found in Africa, they're found in Europe, they're even found into Asia. So we think people were doing a lot of things with them. Processing plants, probably making flakes, maybe even bashing open bones to get at marrow. But whatever they were doing, these tools were pretty useful for doing that for over 1 million years.
Right. So these tools, are quite a bit larger. What about these here?
So really, as was the trend in cell phones for quite a while, though not so much recently, but tools got smaller through time. Mm-hmm. And so really once you start getting smaller tools like this, that was the advent of hunting technology.
Okay.
So these are spear points. First you see points that are hafted onto a wooden shaft to make a spear that was either thrust or thrown. And then once you start getting arrowheads, being able to put a little bit of distance in between yourself and the thing you were hunting made things a lot safer. And then once we get really later in time, then you start getting things that are so finely crafted that there were probably really an aspect of craftsmanship and aesthetics that went into making these beautiful tools.
Awesome. Very, very interesting. So just again, we're here with, if you're tuning in, we're here with Dr. Pobner, and she is a paleoanthropologist, mm-hmm. and she is talking to us a little bit about what our early human ancestors would have eaten. If you want to, feel free to chime in and ask us some questions for the good doctor. We will certainly take those. Okay, so we're coming up on Thanksgiving.
We are coming up on Thanksgiving. Okay.
If
excited.
I'm no one's more excited than I am. If I'm an early human, I've got, I'm hanging out in my cave mm-hmm. with my clan, I assume. What am I eating? Am I eating like, how about, all right, rapid fire. I'm going to ask you things, and you
Okay.
tell me if we're eating it.
Okay.
Cranberry sauce.
No.
Okay. Turkeys.
Turkeys, not until about 1,500 years ago.
Okay. All right. Yeah, I'm from before then. So what about mashed potatoes?
Mashed potatoes, probably a few thousand years ago, but actually was not on the earliest kind of American Thanksgiving dinner. They were domesticated in South America, but didn't make it to North America until the 1800s.
Okay. Sweet potatoes.
Sweet potatoes, potentially. Sweet potatoes are actually the original naturally genetically modified organisms. So about 8,000 years ago, a gene from a bacteria inserted itself into sweet potatoes and basically made them more palatable.
Okay. So we've got yes to sweet potatoes.
Depending on what time period.
No to
So,
turkey. No to
yeah.
cranberry sauce. Honestly, this Thanksgiving sounds pretty terrible. What else? What else do we got? Pumpkin.
Pumpkin. So we wouldn't have had pumpkin pie, but probably pumpkins. And actually, pumpkins are an interesting story. So about 10,000 years ago, pumpkins and squash, several of species in that family almost went extinct. So they used to be spread basically by mammoths and ground sloths and things that would eat pumpkins, which grow around the edges of kind of open areas. So they would eat them, they would poop them out. I don't know if you want to talk about mammoth poop over your Thanksgiving dinner, but that's how pumpkins were kind of spread. But when people came to North America and started hunting these animals to extinction, the pumpkins didn't have a way to propagate anymore. But thankfully, people started to domesticate pumpkins probably first for use as storage items for gourds.
Gotcha.
And so at that point, they were probably very bitter and even toxic, but people started selecting for the flesh of these to be more palatable.
Awesome.
And then we got pumpkin pie.
Yes. I'm really glad that's what I'm going to take
I
away.
am too.
Okay, so as far as the paleo diet goes, there's a lot of discussion about evolution and that kind of stuff, about starches and dairies and that kind of stuff. You were telling us a pretty interesting story earlier about dairy. Will you share that with us?
Yeah, so dairy, the ability to digest lactose, which is the sugar in milk and dairy, is one of my favorite stories of recent human evolution with really strong natural selection. So there are several different mutations that we see in modern people who can digest lactose as adults, so we all can digest lactose as babies. But interestingly, for most people, the gene for lactose digestion gets turned off at about 2, the traditional age of weaning, when kids aren't drinking breast milk anymore. But about a third of the people on the planet today can digest lactose. And if we look at ancient human skeletons, kind of ancient, we don't see this mutation in human skeletons dating back earlier than about 7,000 years ago, but starting 5,000 years ago we do.
Okay.
And so this seems to have been a strong, really strong natural selection for multiple mutations, mostly in populations where they were domesticating dairy animals like cows and goats and sheep and things like that. Being able to drink milk. Milk is a great source of fat, a great source of protein. It's a source of clean liquid. When you start living with animals, a lot of times your water sources get contaminated. So when people were moving crops around the world with the advent of agriculture, they were moving crops to areas where they hadn't naturally been occurring. You get famines. If you have another source of food and you can survive, there's really strong selection pressure.
Okay, I
to be
see.
able to
So
digest
if you run
lactose.
out of other food, you still have the ability to get dairy from the animals, and
Exactly.
then so that's basically, I guess what I'm taking away from that is, although it was a recently quick step, I guess, in evolution, because the selective pressure was so strong. Okay.
And now we have more than 7 billion people on the planet. About a third of people can digest lactose as adults. So that's like a blink of an eye in evolutionary history.
Absolutely. So you said those genes get turned on or turned off after about age 2. Can you turn my lactase genes back on?
Oh,
Basically, I'm here for you to tell me how I can eat ice cream again.
Lactose-free ice cream.
Okay, that's it. All right,
So.
fine. Fair.
We have some questions coming in.
Absolutely.
Arnold wants to know, did the paleo diet include insects?
Oh, yes. So actually the paleo diet, we see modern primates eating insects. We see modern people eating insects actually around the world. Some of the earliest evidence comes from a site in South Africa where people were using tools to dig into termite mounds. And when you dig into a termite mound, the termites come up and swarm, and you can just basically pick them off like termite popcorn.
Wow, awesome.
So.
Sounds great.
Maybe to some people.
You got another one?
Rose is asking, when did grains come into the picture?
Oh, grains came into the picture a lot earlier than people think. So there's some evidence from, again, those starches on the edge of stone tools that about 100,000 years ago, people were processing wild ancestors of the grains we eat today. And there's also a site in Israel that's about a little more than 20,000 years old, where people were clearly using tools to grind grains and actually baking them in ovens. They were like paleo pitas 20,000 years ago.
Again, delicious. All right, very cool, very cool. All right, so I think that that's all my Thanksgiving Day questions, right? And you said you had one more.
I do have one more fun thing to show you.
Yes.
So let's go out into the hallway and look at some of my
Science.
collections.
So these are your collections.
These are my collections.
I think, one thing that I don't think people understand is that the people that work at the Smithsonian are actively doing research,
We
right?
are, and so we have lots of gorgeous exhibits, but behind the scenes, there are dozens and dozens of us that are doing active research. A lot of the research that I do is in Kenya and other places overseas, so the fossils that I study stay there, but the things that I can bring back, at least on temporary loan, are some of the objects that I was studying for my dissertation. So I'm interested in the earliest meat eating, how people came to get the meat and marrow that they were eating in the past. We have fossils that have butchery marks. We know people were eating meat back to 2.6 million years ago. But hunting technology wasn't around until 500,000 years ago. So I think probably the earliest humans were scavenging.
Right.
And meat from leftovers from predator kills.
Absolutely. And you did some research actually that's pretty interesting about, what's left over after carnivores come through. So tell us a little bit about that.
I did. So I did a study as part of my PhD in central Kenya in a game reserve called Oldowan Conservancy. And I was kind of following lions around, basically being a scavenger. So I would wait until they were done eating the animals that they were eating, and I would go in and I would document how much meat was left, what parts of the carcass the meat was on, and then after that, getting a sense of kind of how many calories are around when the lions are even finished and they're full. I would actually pick up the bones because I'm also trying to study the patterns of chewing that carnivores do in the present. If I can identify patterns specific to lions or leopards or other carnivores that we think that early humans would have scavenged from, I can look at fossil assemblages with carnivore chewing and say, oh yeah, we know that early humans were butchering fossils here. We also know that some of them were eaten by lions. And so scavenging from a lion or a pride of lions, they usually live in big groups. They're oftentimes out during the day, and they're terrestrial. They live on the ground. But if you're scavenging from leopards, leopards are usually solitary. They often hang out in trees, and they stash their kills there. So that has an implication for tree climbing and maybe social group size. So we can actually tell a lot just from figuring out what kinds of carnivores people were competing with.
Right, absolutely. Okay, let's look at your bones.
So I have bones here. These are all femora or femurs, it's your upper leg bone, from zebras that were eaten by lions at this place, this reserve in central Kenya. And so one of the things I'm interested in looking at is the pattern of chewing. And so you can see one difference between these two bones is that this bone, the one on the right, had chewing damage on the top and this one didn't. So how much variability is there? Is there kind of a lion chewing pattern? That's one thing I'm interested in. And so sometimes, depending on whether the zebras were adult or juvenile, sometimes the lions just really hammer at them. And so you could see the ends of this femur were just totally chewed off. This was a young zebra, it was a young individual.
Gotcha. So that's cool. So you're taking these patterns that you've noticed in the present, you're able to go ahead and apply them
Exactly.
to the past. Very cool. Awesome. Very awesome. So do we have any more questions that we would?
A couple people have asked about the earliest cooking. When did we start
Ooh,
cooking?
that's a great question. So the earliest evidence for cooking goes back to about 1 million years ago. There's a site in South Africa that really we have evidence for cooked bones and plants deep inside a cave. Wasn't any kind of natural fire. There's another site about 800,000 years ago in Israel that has multiple layers of campfires, basically. There's burnt bones and seeds and plants. And so we know that people were basically coming back there to cook over and over again.
Wow.
So you have meat eating 2.5 million years ago, cooking 1 million years ago, hunting 500,000 years ago. So there were kind of these stages in the evolution of our diet.
Very, very cool. Well, as far as from NPR, we just wanted to thank Dr. Pobner and this
You're welcome. This was
Smithsonian for allowing us to get a little bit of a glimpse of our early diets and our early ancestors. Thank you.
You're welcome. Happy Thanksgiving.
Happy Thanksgiving.